Hello everyone, my name is Andrej Iskra and I would like to wish you warm welcome also on behalf of my co-worker and co-author of this paper, Helena Gabrijelčič Tomc. We come from the Faculty of Natural Sciences and Engineering, University of Ljubljana, and you can see also my email address for later contact. Today I will present you the analysis of observing and recognition profile facial images using eye tracking system. Okay. Let's see. Introduction. So basically we have 5 web elements: text, images, animation, sound, and video. And among images we have facial images. When considering recognition and memorizing facial images, there are several factors that is important. These are dimensions, the view of presented face, so frontal, mid-profile, and profile, and express emotions. There has been a lot of research also on emotion recognition. Even me and my coworker has done some of the researches in the past. And we used eye tracking system, which is treated as an objective method for obtaining results. We face in the lack of research studies for the profile facial images. There has been a lot of studies for the frontal facial images, but not that much for the profile facial images, how we look them and how we memorize them. So we try to find out what is the influence of presentation time on memory and recognition of these profile facial images. The influence of dimension of facial images on memory and recognition. According to that, we obtain the results of recognition success and incorrect recognition, false alarm, and fixation duration, and also saccade length as 2 results of eye tracking system. So we made our tests divided in 2 parts: observation and recognition test. It is commonly referred as yes/no or a memory test. We had 48 participants from students of our faculty, 15 male and 33 female, the average age of 20.3 years old, and we got facial images from the database face database Mineral and Park. We took 40 facial images, 20 male and 20 female. So first observation test, we defined 4 different presentation time: 1, 2, 4, and 8 seconds. So each test has only 1 defined presentation time and 2-dimensional facial images. We named them middle and large one. And concerning these 2 factors, we had 8 different automated tests. In each test included 20 profile facial images, 10 of male and 10 of female. And as you can see, this was the procedure. So after the instruction, there was a black screen for 2 seconds for the neutralizing of the gaze of the participants. Then it was facial images presented for one of these 4 preset times, and again black screen, and this was 1 pair and 19 other pairs till the end of the test. After the observation test, we performed the recognition test, which contained 40 profile facial images, 20 from the observation test and 20 new one, and it was participant controlled. So as you can see, after the instructions, there was again a black screen, and then was presented the facial images, and the participants had to answer whether they saw this face in the observation test or no. So it was a new one, and it was 40 profile facial images till the end of the test, and all the answers were took manually and then transferred into electronic way. The analysis of result, as I told you before, it was recognition success, which is normally presented as a discrimination index. This discrimination index is calculated according to this formula. CR means correct recognition, FA means false alarm, and the maximum value, so if all the answers for correct recognition was done and there was no false alarm, so no recognition, this A would get a value of 1. There was, of course, also incorrect recognition as a false alarm. This was the case when the participants answered that for a certain facial image they said that they saw these facial images in the observation test, but the fact was that these facial images was not in the observation test. So they made a mistake in the recognition process. Fixation duration was obtained directly from the Tobii Studio as one of the feature, and saccade length was calculated as a distance between two consecutive fixation. So we come to the results and discussion. Recognition success, we presented recognition success according to observation time. So for each observation time 1, 2, 4, and 8 seconds, we calculated this recognition success, and we can see that we got two curves, and both of the curves means that longer observation times resulted in better recognition success, which is quite logical, because if the participants saw the face for a longer time, they memorize it better, and of course the recognition success was also better. The dimension of facial images has no influence on the recognition success. We see these curves are more or less the same, the same shape and the same results. Some previous studies that we have done with Helena showed that if the dimensions are smaller, then the recognition success get worse. But for these dimensions that we had here, the dimensions practically have no influence. We defined logarithmic curve as a function of observation time. We assume that even before the test, and we applied this logarithmic curve, and we get very good adaptation to the actual results. So determination index coefficient R square is quite high. For one case 0.93, and for other case 0.97. So this logarithmic curve can be used to predict the results of recognition success for the observation times other than times that we have. And we can see the turning point at the 4 seconds of the observation time. So for the observation time less than 4 seconds, this recognition success has quite steep curve, so it's improving with a longer time. But times longer than 4 seconds doesn't really improve the recognition success. So it doesn't really matter when whether the participants looked the facial images for example 4 seconds or 8 seconds. And 0.95 is in science community treated as a satisfactory recognition. So we get this level at observation time of 4 seconds. And again, so this is kind of a turning point in the results. Incorrect recognition as a false alarm. Again, we can see that longer observation time means less mistakes in recognition. So false alarm or incorrect recognition is lower. And again, this actually is we can say that only for times less than 4 seconds. If you increase the observation time, this false alarm or incorrect recognition stays pretty much the same, around 10%. Doesn't drop significantly as for the times shorter than 4 seconds. Again, dimension of facial images has no influence on the correct recognition. They are pretty much the same. Here we are talking 1 or 2 faces that were wrong recognition these points between these two curves as a dimension. Again, turning point at 4 seconds, as I explained before. And the next was fixation duration. Fixation duration meant that longer observation time resulted in longer fixation duration. This is due to the fact that if you present a face for a shorter time, eyes is kind of nerved and jumps between fixation very rapidly, so they are shorter. If you have a longer presentation times, eyes can kind of calm down, and observation is in more relaxed manner. So the fixation duration is longer. And we can see here again at the 4 seconds observation time, the curve got flattened. So this fixation duration doesn't get longer as much as for the shorter observation time. And larger dimensions of images resulted. It means that the faces are larger, and of course facial features are larger. So according to the threshold that we can set for the definition of fixation duration, it means for the particular facial feature like eye, there are more fixation there because eye are bigger. Eye is on the large image is bigger. There are more fixation, and more fixation in the same time means shorter fixation duration. So for the larger images, fixation durations are shorter. Saccada length. Again, from the curves, we can see that larger observation times mean longer observation times means longer saccada length. It's quite obvious because in the observation time of 1 second, the gaze of participants mostly stay in the center of the face, so on the internal facial features like eyes, nose, and mouth. And if you make observation times longer, so participants had more time and they observe even the other facial features like cheek and ears and beard and forehead. So in that case, saccada length were longer. At 4 seconds, we also again see the curve got flattened. It's not that obvious as fixation duration, but we can see that the curve is steeper for the times from 1 to 4 seconds and more flattened for the times longer than for example, from the time 4 seconds to 8 seconds, it's more flattened. And of course, larger dimensions means that images are larger and they resulted in longer saccadas, so longer eye movement of the participants, which is quite logical. So we can make some conclusions that longer observation times means better memory and resulted in better recognition and also less incorrect recognition. This fact is valid up to the 4 seconds of observation time. Longer observation time doesn't improve memory and doesn't improve recognition. So recognition success was pretty much the same, and also incorrect recognition was the same. So this first definition is actually valid up to 4 seconds. Longer observation time does not improve memory and recognition, as I just said. And 4 seconds of observation time was proven with eye tracker data. So fixation duration and saccada length also get flattened. This curve get flattened from the 4 seconds up to the longer observation times. Similar results was obtained also for the frontal facial images from some other studies, also from some studies that we have done with Helena. For the frontal facial images, we get similar turning point at the 4 seconds of observation time. And for the future, we need to evaluate these results also with the internal facial feature method. So the measuring of the internal facial features like eyes, nose, and mouth. And with the heat map analysis, this is quite a new method that was presented first time in my PhD, and we have done some analysis already and still some work on this heat map analysis in the future. Thank you for your attention. If you have any comments and answers, you can contact me on my email. You can even contact the organizers, and they will forward these comments and answers to me. And at this point, I would like to thank the organizers who implemented these conferences in the best way possible according to the situation that we have. So thank you again also for the organizers.